Hi guys! Welcome back to my channel. This is Teacher Sushmita, and for today's episode I will discuss the Boyle's Law. Boyle's Law states that in a closed system, pressure and volume of an ideal gas are inversely proportional, so long as its temperature and mass remain constant. In order to perform this, we need to have the following materials: a large syringe and a small balloon. Even though we will not be dealing anything hazardous in this activity, it is always important to remember the laboratory precautionary measures. First is, wear proper lab clothing. When you are working in the lab, you need to wear the right attire to keep you safe. Wear lab coats, closed shoes, gloves, and safety goggles if necessary. Also, you'll have to tie your hair back away from your face to avoid any contamination of testing materials. This will also keep you safe if you are working with any flammable materials. Second is handle chemicals with care. While handling chemicals in the lab, you have to read the instructions for safe handling. The third one is properly care for the equipment. A lab has many different heavy-duty pieces of equipment that are necessary in testing samples. You should always handle this equipment with extra caution and care. Fourth is, always locate emergency equipment. You should always familiarize yourself with this emergency equipment so that you know where to locate it in case the situation arises. The last one is keep food and drink out of the lab. Keep your food and drinks out of the lab. This can easily contaminate or pollute your testing samples, which will produce inaccurate results that require retesting. Drinks can also spill, which will create messes or tripping hazards in the lab. The first step in our experiment is to blow up our small balloon. Keep in mind that the size of the inflated balloon has to fit inside the syringe. Once you have achieved the desired size, you have to tie up the balloon and then you're ready to go. The second step would be drop the balloon inside the syringe and put the plunger in the end. For our first test, put the plunger at the highest point of the syringe and cover the bottom opening with your finger to form a seal. Press the plunger down and watch as the balloon shrinks in size. Now, remove your finger from the bottom of the syringe to release the pressure. Let's proceed for the second test of our experiment. Place the plunger at the lowest point it can be without touching the balloon. Once again, place your finger over the opening of the bottom of the syringe and pull the plunger upwards and watch as the balloon increases its size. To remove the pressure, remove your finger from the bottom of the syringe. Let's take a look on our experiment. Boyle's law states that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. Thus, at constant temperature, when the volume of a gas increases, the pressure decreases. And when the volume of the gas decreases, the pressure of a gas increases. An ideal gas is a theoretical gas composed of randomly moving, non-interacting particles. The ideal gases obey the laws of ideal gases such as Boyle's law, Charles' law, and Gay-Lussac's law. Examples of ideal gases are oxygen, hydrogen, and carbon dioxide. In our experiment, the balloon and syringe are filled with tons of gaseous air molecules. Placing your finger over the opening at the bottom of the syringe keeps the mass of air molecules constant and creates a closed system that will allow us to manipulate the pressure and volume. When we press the plunger down, we are increasing the pressure being placed on the air molecules inside the syringe by reducing its volume. As the pressure increases, the amount of force placed on the air molecules increases, and they're forced closer and closer together, decreasing the volume of space that our gas takes up and shrinking the size of our balloon. When we remove our finger from the bottom of the syringe, we release the added pressure and our balloon goes back to its original volume. In the second portion of our experiment, we start with the plunger at the bottom of the syringe almost touching the balloon. When the plunger is pulled upwards, we are reducing the pressure inside the syringe by increasing the volume of space the air inside takes up. This decreasing pressure and increasing volume pulls the air molecules farther apart, increasing the amount of space the gas takes up, growing and expanding the size of our balloon. Removing your finger from the bottom of the syringe returns the pressure back to normal, reducing the volume and size of our balloon. When we compare the two variations of this experiment side by side, we can clearly see the inversely proportional relationship between the volume and pressure of an ideal gas. This relationship is known as Boyle's law. Well, that's it for this episode about Boyle's law. Thank you for watching.